my name is Luyen Hern's metric number AD190223. Now, me and my group are going to present an experimental video to demonstrate the heat transfer phenomena. Now, I would like to introduce my group member, that is Mahendra Analaki Ravi, AD190064, Lok Yongjian, AD190223, and Maxwell Kedu Anak Intri, AD190141. There are three heat transfer phenomena that we are going to present, that is conductions, convections, and radiations. Before we start our experimental video, I am going to briefly explain about what is conductions, convections, and radiations. Conduction occurs through direct contact. When two substances come into contact, their particles collide. The energy from the faster moving substance is transferred to the slower moving substance until they are moving at the same speed. At this point, their temperature will be the same. Convection is the transfer of heat in the air or a fluid through currents. An example is a pot of water warming up on a hot stove. As it heats up, the particles spread out and become less dense. The warm water at the bottoms of the pot rise and displace the cold water. As this occurs, the cold water sinks. So, hot air rises, cools, and falls. Radiation is the transfer of energy as electromagnetic waves. It does not need to directly touch anything or move particles as in conductions and convections. Radiation occurs through empty space, as in the sun hitting the earth or feeling warm in front of a fire.
Hi, I'm Loinjen, metric number AD190213. For the heat transfer group project, I'll be judging for the experiment of heat conduction. For the apparatus that we're going to use for the heat conduction experiment will be a candle, metal stick, a lighter, some clip, and also some screw. We begin the procedure by lighting up the candle. Then we wait for the wax to be melted. And then we stick the screw on the metal stick. Once the screw is successfully fixed on the metal stick using the melted wax, we will arrange it according like this by clipping the metal stick on the surface. We now begin our experiment by heating up the tips of the metal stick. As we can see, the screw slowly drop down one by one after the wax is melted. Now let me explain the phenomena of the falling of screw from the metal stick after the melting of wax, even though the heat did not apply directly to the wax. This phenomena can be explained by the theory of heat conduction, where the process of conduction can be simply explained by the transfer of energy from a region of high temperature to a region of low temperature. Conduction of the thermal energy takes place when the local interaction between the molecules passes kinetic energy from side to side without net movement between each another. In this case, when the heat is applied at the tip, the particle at the tip of metal stick will gain kinetic energy and start to collide with nearby particles and result in the process of heat energy transfer, where the wax will then melt and result in dropping of screw. As the conclusion of this experiment, we are able to prove that the heat conduction process happened when the screw dropped because of the melting of wax. The transfer of heat energy from the collision between the heat particles with the cold particle are also proved, as the heat are only applied at the tip of metal stick. Thank you.
Hi, I'm Mahendran. I would like to conduct heat convection experiment. Before we start our experiment, let's take a look at the equipment we need for the experiment. All we need is a pencil, a scissor, a lighter, sticks, a candle, a piece of paper, and a shield. Let's begin our experiment. First, we have to draw a circular pattern like this, and then we have to cut the circular pattern accordingly. After we cut the pattern, the outcome will be like this. First, we light up the candle. Next, we cover the candle with a shield. After that, we put the circular pattern on top of the stick and then bring it towards the flame. As you can see, the paper starts spinning. Now I'm going to discuss the conclusion part. As we saw, heat convection occurred in this experiment just now. As the result of the experiment, the color paper starts to spin when we place it near the flame. This happens because of the heating air, which causes the air molecules to travel further apart, thereby making the air less dense. Less dense air will always rise above dense air. As the warm, lighter air rises upwards, the circular pattern begins to spin. We can say that heat convection is the transfer of thermal energy by actual physical movement from one location to another location of a substance in which thermal energy is stored. Besides that, heat convection is often the primary mode of energy transfer in liquids and gases. That's all for heat convection. Thank you very much for watching.
Hi, my name is Luyan Hans, and now I'm going to do a small experiment about heat transfer through radiations. This is the material needed on this small experiment, that is ice cube. For conducting this experiment, I'm going to let ice cube expose under the sun for 15 minutes, and after 15 minutes, we will see what will happen to this ice cube. After 15 minutes, the result has already come out. From the result, we can see that the ice cube has already completely melted after exposed under the sun 15 minutes. And for the reasons why it melts, I will further discuss in my explanation part. Now, I'm going to discuss about why the ice will melting under the sun. But before that, let me explain what is heat transfer with radiations. Heat radiation is electromagnetic radiations emitted from a material that is due to the heat of materials, the characteristic of which depends on its temperature. Heat radiations is generated when heat from the movement charge in the materials, electrons and protons in common form of matter, is converted to electromagnetic radiations. Sunshine or solar radiation is thermal radiations from the extremely hot gases of the sun, and these radiations hit the earth. From the experimental video, we can show that the ice cube melt after being exposed under the sun for about 15 minutes. This is because the sun is shining on the ice cube. When the sun is shining on the ice cube, some of the solar energy will absorb by the ice cube. The sun will emit the heat through radiations which the ice cube will absorb, and thus this will increase the ice cube energy gains. If this energy gain exceeds the energy loss, the ice will become warm. If it reaches the melting point, the ice will start to melt. That's all for my parts. Thank you.
Good morning, my name is Maxwell, and today we'll proceed with the heat transfer by radiation. So for the experiment, we'll be needing two cloth of the same brand with different color. One is dark and one is lighter color, maybe like white. For this experiment, we'll let the two cloth to dry under the sun for at least 15 minutes. After that, we'll come back to touch the shirt and feel which one is the warmest temperature. So after 15 minutes, we'll begin to determine which one has the warmest temperature between the two cloth. This one is the cloth with the blacker color, and this one has the lighter color. Based on my observation, I found out that the cloth with darker color is warmer than the one with white. Good day, my name is Maxwell, and today we'll proceed with the conclusion part for my part, radiation experiment. So in conclusion, radiation is demonstrated in this experiment by the lighter cloth and the black cloth that we expose under the sunlight in 50 minutes. For this experiment, we can see that the appearance of surface determines the rate of emission and absorption of radiation for the two cloth. For the dark cloth, it warms up faster because the surface emits and absorbs radiation energy more efficiently compared to the cloth with the lighter color. This is because compared to the cloth with whiter color, it's absorbed and radiated energy more slowly because the surface reflect the radiation of the sun. Hence, that's why the darker color cloth warm up faster compared to the white one. Thank you.
Thank you.